Hello, I'm Sammy Radikop, and I'm here to demonstrate my project for ENSE352 on November 21st, 2021 at approximately 10:50 a.m. here, or p.m. here. So this is my second attempt at it for my second part of the second take of the class here. So go through my code here first. So all these here are various register addresses or values that need to be written to those registers. Here are all these different values that can be adjusted for your different delays, or you can adjust the values for the LCG, random number generator algorithm. Different things for the main game part, or the success or fail sections, different timings. Just some setup stuff here, blah, 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 blah. So first we go to register initialize. This sets up ports A and port B. Port A, pins 4, 5, 6, and 7 are used as outputs. And PB 5, 6, 8, and 9 are used as inputs with internal pull-down resistors. I'll note that here. With internal pull-down resistors. So that all gets set up there, yada yada. Then we finally load into R0 and R1 the addresses for the ODR and IDR register that need to be used for writing to my LEDs and for reading of the push buttons. So those values will not be touched for the rest of the program. So then you see one here. This is you're just waiting for player, and it just lights up each LED one at a time. But then in between lighting up each LED, it samples the buttons here using this algorithm I came up with, and basically checks if any of them are pressed, then it jumps to the main game here. If not, then this just goes back and just lights up the next light. Nothing special. So UC2 is the main game. So again, first we load in main delay time, and this time gets halved every round. And then we make sure that R4 is 0, as this is our round counter. And we turn off LEDs if they're anywhere on. So then the first part here, this main loop, we select our LED. So we're loading the prelim delay, and then we do our preliminary delay for the round. So it does that. That's just the time in between rounds. Then we load in our two LCG A and C values. Then we check, has the player beaten all 15 rounds here? And if we do that, then they've won and they go to the UC3 section. So then we do the base random number generator here, LCG thingy. Then we extract bits 26 and 27. And so that'll be a value of either 0, 1, 2, or 3. We then add 4 to this to get a value between 4 and 7. And so then we can use this to get either 16, 32, 64, or 128, which is the corresponding to where the LEDs are assigned on the ODR port or register of GPIO port A. And so then load in here, and then just depending if there's 4, 5, 6, or 7 in there, that is loops this how many ever times, and that gets our final random number for the corresponding LED to light up. So then we take that and turn on the LED there, and then we load in our time for the round into R6 here and do our main delay and sample loop. So check, are we out of time? If we are, then player has failed. Just all these no ops here, just add to the delay here. Then we sample the buttons, so that'll be into R7. So then we do some blah 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 thing here, and R7 is our final value from the buttons. So then we check if if R5 and R7 match, and if they have, then they've won that round. If the R7 is 0, then we know no button has been pressed. And obviously, if R5 and R7 have disagreed and R7 is not 0, then they have failed and they go to the fail routine. So there's no button pressed. pops us back up to the top here, and we keep sampling the switches. And so then if the player has won the round, we go to round 1 here. And so then what happens is R2 is our seed register for LCG algorithm. So we just load the remaining time into there. So the remaining time is I would say a fairly good random value to use. So you get a fairly random selection of LED. Then we turn off R0 here, turn off all of our LEDs, and then we branch back all the way. So we did a BL here. So then now what happens is we finish the round we add 1 to our round counter because the player beat the round, and then we divide the time in half for the next round, and then we go back to selecting our LED. And so that all repeats. Now say that the player has say the player has beaten all the rounds. So that means where are we? So that means we compare is R4 equal UC2 number of rounds, and if it is, then the player has won, and they go to section UC3 here. So that's the end success section. So again, we just count down here, and we need to do this thingy 5 times, and then we go back to game reset, blah blah blah. But so here, turns on all 5 LEDs, turns them off again, and it repeats that 5 times quickly, and that's your winning signal. And it's just a little delay loop in between turning them on and off. Blah 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 blah. And then once it's done that, it just goes back to game reset 1 here, where game reset 1 takes us back to UC1, where we go and wait for the player again. I couldn't quite get to branch back to UC1 due to some weird thing with how many lines are in between here, and it couldn't be encoded properly. So I just had to use this intermediate little function guy to do it. Now, say the player has failed. Well, what happens is, so we turn off the LEDs, and again, this will loop 5 times here. So it turns on the bottom 2 LEDs first, then the top 2, and it does that 5 times to indicate that you have failed. And then once that's done, then it goes to this display round number thing here. So that just takes the how many rounds the player has beaten in R4 there, and just shifts it over by 4 so it can be displayed properly, and writes to display, so it just tells you how many rounds the player has done, and then it holds that on the display for however long, and then goes back to game reset 1, which goes back to UC1, and so the game is being reset. So yeah, that's the code here. So now I will do a little demo. So we will just plug in to power here. So we can see there the LEDs light up one at a time. Let me just adjust this a little bit. There we go, so we can actually play the game. So just go one at a time, and it's just waiting for the player to initiate a button. So we will press a button to start this. Go. Green. Red. Green. 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 Red. Blue. Red. Green. Blue. Black. 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 Damn it. Ran out of time, so I failed there. Okay, let me see if I can try this again. So yeah, I beat 14 rounds there. And it just holds that there for a second to say that I beat 14 rounds, and now it just goes back to there. So let's try this again. Damn it! Pressed the wrong button this time. Fruitcake. And so yeah, 8 plus 4 is 12. I'll be 12 rounds this time. Fruitcake. Damn it. Okay, well that's the... No, I gotta keep trying this. It's a little bit too short. Okay, well that's the best I can do. No, I gotta keep trying here. Okay, I'm just going to try and slow this game down just a little bit. Since I'm just a little too fast on the last round, I need to display the winning signal. Okay, so where's my cursor? There it is. So we need to main delay base. I'm just gonna speed this, slow this down just a little bit. There, that should work. Build, flash. Okay. Restart this. Okay, let's try this again here. Yes, I won. There we go, and that's when you win. It just goes back to the thing. Alright, well that's my demonstration for my ENSE352 project for fall 2021 here. Hopefully it is to the marker's liking.